It is okay.
Yes, sir.
It was assumed that this Px, Qs, and Rx continuous function functions uh, on a common interval I. Right. So first thing we find out is Yc, which is C1 Y1 plus C2 Y2. So find this where this Y1 and Y2 are linearly independent solutions. Another name for these is fundamental solutions of Ly equal to. So first thing we find out this Yc. Then we try to find out Yp, which is like Yp, a particular solution of Ly equal to. Then we have already discussed that the general solution of Ly equal to Rx can be written as this Y is equal to gen, sometimes you can write YNH also, just to emphasize that it is the general solution of the non-homogeneous problem, not the homogeneous problem, and it is written as Yp plus this Yc, right? So this thing we have already proved in last class, that the general solution of Ly equal to Rx can be written as Yp plus Yc. I hope you remember all these things. Then we were discussing methods to find y. So it means that once we know that we can write down the general solution like this, we have already discussed certain method to find out this Yc in the case of constant coefficient. Then if we know how to find out this Yp, then we can find out the general solution. Okay. So here, this we have discussed it or not? How to find out this Yc in the case of constant coefficient. We have done it or not? How to find out this Yc? Is it done? Anybody? This is second order. Yeah, this is Cx, non-homogeneous column. Theorems we have, okay, this we have done. Okay, proof is also done. And then, okay, okay. So here we actually try to find out the Yc. Okay, okay. So we are still on the how to find out Yc. Okay. Yeah, please. I think method to find Yc still is going on. I see. Now here, when coefficients are constant, coefficients are constant. So it means that we have y double dash plus p y x y dash x plus q y equal to 0. So Rx is identical to 0 is given, p and q are constant. So we have discussed that the solution of this can be assumed in the form of e to power mx, right? So why? Because this is the only function whose derivative is nothing but constant multiple of itself, right? And hence, if we put it here, then there is a possibility. Now, if I put it here, then we have this equation m is square plus pm plus q e to power mx is equal to 0. So e to power mx is not 0. So we can have pm square plus pm plus q equal to 0. So it means that if m satisfy this equation, then y equal to e to power mx will be the solution of this equation. Okay. So here, since it is a quadratic equation, then based on the nature of this m roots, nature of the roots, we have three different cases. I think we have done case one when we have distinct real roots. So distinct real roots, it means that this p square minus 4q is greater than 0. Why it is? Because here m1, m2, I can find out like this, minus p plus minus p square minus 4q upon 2. Right, so if discriminant p square minus 4q is positive, then roots will be distinct and real. Okay, and then you can write down the solution as y1 e to power m1x and y2 equal to e to power m2x. And these are linearly independent solutions. So they will form a fundamental set of solutions. Case 2. This was the last thing which we are discussing here. So we have distinct complex. So it means that p square minus 4q is strictly negative. So it means that here in this case, you have m1 and m2. It will be like alpha plus I beta and alpha minus beta. Right, so it will be complex, and we have shown, I think this was the now okay, so here we can show uh, I was claiming that e to power alpha x cos of beta x and y2 equal to e to power alpha x sin beta x are two linearly independent solutions. This was, I think, claim. Now, I request all of you that whenever we come here, then please stop me if I am doing the back thing, because right now we have almost invested whatever you say, 9 minutes in recalling everything. So only few things we can recall. I think we can recall from this onward. Anyway, so we got this. Now, have I given any kind of a homework to show that first of all we need to prove that these are solutions, and then we have to prove that these are linearly independent solutions. So have you done this part? Yes. Any one of you? Am I audible first of all? Because
Yes, sir, I have tried, but sir, not getting it. Like I am making some mistake again and again.
okay, okay, so fine. Okay, so claim. Now let us prove it. Claim that if uh, your fx plus igx is a solution of y double dash plus py dash plus qy equal to 0. Then fx is a complex solution. Then fx and gx are two real solutions, real solutions of ly equal to 0. Okay, so it means that here, once we know a complex solution, then this claim says that then its real and imaginary part are nothing but real solution of the same equation. So I think this is not a difficult thing to prove. Let us prove here. So since fx plus igx is a solution, so it means that if I replace y by fx plus igx, then it will satisfy this equation. So it means that fx plus igx double derivative plus p fx plus igx derivative plus q fx plus I. This has to be 0 here. Now, find out the double derivative. F double dash x plus I g double dash x plus p. And this is fx f dash x plus I g dash x plus q fx plus igx. Now, write down the real part and imaginary part separately. So we have f double dash x plus p f dash x plus q fx plus. g double dash x, I am taking out, so g double dash x plus p g dash x plus q gx is equal to 0. 0 can be written as 0 plus I0. Okay, so it means that if this quantity is equal to 0, then its real and imaginary part itself will be 0. So this implies that f double dash x plus p f dash x plus q of x is equal to 0, and your g double dash x plus p g dash x plus q gx is equal to 0, and which shows that fx and gx are real solutions of. Is it okay here? Both of like all of you, solutions of LYP. Yes. Now, next thing, which so it means that if this I think corresponding to this alpha plus I beta, it is e to power alpha cos of beta x plus I sine beta x. Right? This is a solution corresponding to this, right? So it means that real part, it means that this e to power alpha cos beta x and imaginary part, that is e to power alpha x sine beta x. This is also two real solutions. Okay. Only thing I want to prove is that it is linearly independent solution, right? So how we can prove that these linearly independent solution? So one way to prove this now, another claim that yx, y1x equal to e to power alpha x cos of beta x, and y2x equal to e to power alpha x sin beta x are linearly independent. So how we can prove it? How we can prove it?
So we can calculate the Wronskian.
Okay. So one simple way is to prove Wronskian. Wronskian of y1 and y2 of x, and it is coming out to be non-zero for each value on R. Because here, when I look at the equation itself, here coefficient P and Q, since it is constant, are continuous for the entire R, right? So here your Wronskian has to be non-zero for all R, right? So I think you are getting this. Another way is to say is this, that since this uh, we have a distinct complex roots, right? So it means that alpha plus I beta and alpha minus I beta are distinct. So it means that the solution e to power alpha plus I beta x and e to power alpha minus I beta x both are linearly independent. Yes or no? Yes.
Yes.
So
Yes.
So here we have, I think, one relation. I think you can get it, that if fx and gx are linearly independent, then fx plus gx and fx minus gx are also linearly independent. Can you prove this result, that if fx and gx are linearly independent, then fx plus gx plus and fx minus gx are linearly independent? So I'm just giving you a small hint of this, and then you prove that if these are linearly independent, then so is e to power alpha x cos of beta x and e to power alpha x sin beta x. So this I'm giving you as a homework. Now hint I'm giving like this. Now I'm just proving this hint. I think proving hint is okay. So fx plus gx are linearly independent. It is given. Now I want to prove that the sum and the difference is also linearly independent. I think it is not very difficult to prove. So let us form the linear combination of fx plus gx and c2 fx minus g equal to 0. So if you want to check the linearly independence of fx plus gx and fx minus gx, form a linear combination of this and equate it to 0, and we try to see that we have only possibility, that is C1 equal to C2 equal to 0. So only possibility is that we have a trivial solution for this C1 and C2. So we just simplify this and we can write C1 plus C2 for this f of x plus C1 minus C2 for g of x. We can simplify like this. Now it is already given that fx and gx are linearly independent. It is given here. So this implies that the coefficient of fx and gx in this linear combination has to be 0. So it means that C1 plus C2 has to be 0 and C1 minus C2 has to be 0. And this is only possible when C1 equal to C2 equal to 0. And if it is so, then here fx plus gx and fx minus gx are linearly independent. Okay. So using this result, uh, can I say that you fill some uh, line here that if e to power alpha plus I beta x and e to power alpha minus beta x are linearly independent solution. Why these are linearly independent solution? Because here we have a distinct values. Alpha plus I beta is distinct from alpha minus I beta, right? So we already know that e to power m1x and e to power m2x are linearly independent if m1 and m2 are distinct. Is it okay? This we already know. So we want to show that from this, we want to prove that e to power alpha x and e to power alpha x sine beta x are also linearly independent. So I'm giving you as a homework. Can you do this? Hint is already given. So I hope that you can do it. If you don't, if you're getting some kind of problem, we'll discuss in next class. Is it okay? So can I leave it here?
Yes, sir.
Okay. Now, next thing, we have distinct complex root or distinct real roots. Now we have a case 3. And this case is like we have real equal. Here we have equal real roots. It means that this p square minus 4q is equal to 0. Right? It means that your m1 and m1 and m2, which is given as minus p plus minus p square minus 4q upon 2. Now this quantity is 0, this quantity is 0. So we have both m1 equal to m2 equal to minus p by 2. Right? So we have only one solution, y1x equal to e to the power minus p by 2x. Right? So how to find out the other solution? Yes, because we need to find out two linearly independent solution. So how to find y2? Yeah, any idea?
So we can assume y2 is equal to some function of x into e raised to minus p by 2x.
Yes. Very good, very good. So you want to assume that y2x equal to some function cx of y1x, right? And then we want to find out, we are finding, I think in previous lecture, how to find out this cx, right? Or you have a formula for cx. Do you remember any formula for this cx? Anybody remember this formula? Or can you find out this cx here? So equation is this y double dash plus p y dash plus q y equal to 0. It is already in a standard form. So what is the value of cx?
So integral of 1 by y1 square into e raised to minus integral px dx.
Integration of p dx.
Dx.
So can you find out what is the cx here? Yeah, what is this value of cx here?
So I think x.
Oh, so you are getting the value of x. So here basically we have x plus c, but since we want only one kind of one solution, so we ignore the constants and we write down x only. So in this case, your y2x is equal to x e to the power minus t by 2x. Okay, so when we have equal real roots, then we have solution can be obtained by method of reduction of order. Is it okay here? I can give an example. Okay, so let me do it. Let us see. Let's see. Yeah, we have say 2y double dash minus 4y dash plus 8y equal to 0. So can you find out the YC here? Find YC means general solution of homogeneous chromatin. Find YC. So how to start? Since it is a differential equation, linear differential equation with constant coefficient. So let yx equal to e to the power mx as is a solution. So we are just letting here. Okay. So we want to find out. So then we find out auxiliary equation. What is auxiliary equation? We put e to the power mx here and we get 2m square minus 4m plus 8 t into e to the power mx equal to 0. So auxiliary equation is basically this. So auxiliary equation, let me write it here. So auxiliary equation is that 2m square minus 4m plus 8 equal to 0. Is it okay here? First thing is let yx equal to e to the power mx is a solution. Then you will get this, you put it here, and then you will get 2m square minus 4m plus 8 e to the power mx is equal to 0. Since e to the power mx cannot be a 0, then this coefficient equation, that is 2m square minus 4m plus 8 equal to 0, has to be true if y equal to e to the power mx is a solution. And we call this equation as auxiliary equation. This thing I'm calling as auxiliary equation. So then once we have auxiliary equation, then we want to find out the roots of this. What are the roots here? It is like m equal to plus 4 plus minus t square, that is 16 minus 4 into 2 into 8 divided by 2 into 2. So what you will get here, 4 plus minus 16 minus 64 upon 4. So what you are getting, 4 plus minus, what is this? 48.
Root 3.
43, right? 48, sorry. Minus 48. Huh? Okay. So what is this? 4 plus minus I, you can take it. What is this?
Root 3.
Root 3.
4 root 3.
4 root 3. Okay, thank you. And so on. So we can get 1 plus minus I root 3. Okay, so it is basically, so here your m1 I can write is 1 plus I root 3 and m2 equal to 1 minus I root 3. Yeah, so can you find out, okay, so this implies that ix equal to e to the power 1 plus I root 3 x is a solution. So is a solution. So it means that you can write it e to the power x, right? And cos of root 3x plus I e to the power x sine of root 3x is a complex solution. Okay? Is a complex solution. Right? And this implies that e to the power x cos of root 3x and e to the power x sine of root 3x are two real solutions. So it means that once we have this, then yc is equal to c1 e to the power x cos of root 3x plus c2 e to the power x sine of root 3x. Are you getting this? How we are writing this? So once we have equation here, then you just check first of all that the coefficient of y double dash, y dash and y should all be constant, right? Once it is constant, then we assume that yx equal to e to power mx is the solution. Once we write it, then we got auxiliary equation. Now, what is auxiliary equation here? That we simply like 2y dash, y double dash. So here y double dash means m to power 2. Here it is y dash means m. And you can write it auxiliary equation like this. So once we have auxiliary equation, we find out the roots here. And based on the types of roots, we decide about the solution here. Now, since we have distinct complex root, then we find out first of all a complex solution. So complex solution we obtain like this. Now, once we have complex solution, then we'll use the result that if this fx plus igx is a complex solution, then fx and gx both are real solutions. So we got it here, and we use that result that these are linearly independent to each other, and we can write down the general solution of the homogeneous problem or complementary solution can be written as c1 e to power x cos of root 3x plus c2 e to power x sin root 3x. Is it okay? I'm just giving you one more example, and you do it. All of you, please do it. So I have to use a thing which is like anyway. I'm writing here. So you write it 2y double dash plus 2y dash plus 3y equal to 0, and then just find out the solution, general solution here. Yeah, please do it. It should not be complex, but anyway, it may be complex. I will it on. What are M1 and M2?
Minus half plus minus 5 iota.
Minus half plus minus
Root 5 iota.
root 5. Okay, so it is minus 1 by 2 minus I root 5. If I take plus sign above. So I think you can find out the solutions. So y1x, you can get it e to power minus half x cos of root 5x, and y2x equal to e to power minus half x sine of root.
So it will be half of root 5 also, I think.
Yes, sir, root 5 by 2.
Okay. So it is something like this. Is it okay here? Now,
Yes, sir.
now here I just want to put a small remark here that in case of complex, we got several kind of a rule. So let us say m1 equal to alpha plus x and m2 equal to alpha minus x. So one solution which I can write as a complex solution. So it is like c1 e to power alpha plus I beta x plus c2 e to power alpha minus I beta x. So this is another one way to write down the general solution. So it is basically complex solution. Then another way we can write it like this. This e to power alpha x c1 cos of beta x plus c2 cos sine of beta x. This is another way to write down this solution. Here it is a real solution. Right. Now, again you can change this thing. Now I hope you already know that C1 cos of beta x plus C2 sine of beta x. You can write it in a very different format, right? How we can write it here? We can say divide and multiply by your C1 is square plus C2 is square, right? So I can write it here C1 is square plus C2 is square, C1 is square plus C2 is square, and multiplied by under root C1 is square plus C2 square. I think this manipulation you have already done in previous class. So C1 is square plus C2 is square. Now inside this, you can write down this quantity as either cos of delta x or sine of delta x. So I can write it here. I can assume this as cos of delta x, cos of beta x, and I can assume this as C2 upon this as, so this is cos of delta x, and you can easily prove then this is nothing but sine of delta x, right? So we can write it sine of delta x and sine of beta x. I can say so. So I can write this as under root C1 is square. Is it okay if I'm writing like this?
Yes, sir.
So this I can write it here cos of beta x minus delta x. Right. So here, this I can write down some other constant. So I can write it here as some C1 big C cos of beta x minus delta x. So this is another way to write down one more real solution. So this YC is another way to write down this. Okay. Now, suppose somebody say that why I'm writing cos delta x, I can write this as sine some other gamma. Let me write it sine.
Excuse me, sir.
Yes, yes.
So in the last expression for yc e power alpha x would also come, or
Where?
in the last expression for yc
Yes. Oh,
e
yeah.
power alpha x.
Yeah. So e to power alpha x will be there because what we are changing is only this part. This part. So e to power alpha x will be there. Okay, so very thank you very much. So c e to power alpha x cos of beta x minus delta x is another real solution. Now again, we can write down this as sine let us gamma x. Then it is automatically cos of gamma x. Right. I can write it like this also. Rather than writing this as cos delta x, I can write sine gamma x. So it means that C1 cos of beta x plus C2 sine of beta x. I'm writing here under root square. And this is what sine A cos B formula, right? So I can write it here sine gamma x cos of beta x plus cos of gamma x sine of beta x. Right? So I can write this as under root C1 is square plus C2 is square, and this is sine of A plus B formula, right? Gamma x plus beta x. Right? And then you can write down yc equal to, call this as c. So c e to power alpha x, and then sine of gamma x plus beta x. Right? So we can write it like this. Is it okay? And where we can say that sine of gamma x is equal to C1 divided by C1 square plus C2 square. Here, similarly, you can get it here as cos of delta x equal to C1 upon C1 square plus C2 square. So it means that here, in case of complex, there are several ways to write down the general solution, right? And you can write answer in any of these particular forms. Is it okay? All of you got this point?
Yes,
Yes,
sir.
sir.
Thank you very much. Now let us move ahead. Now we are moving to find out particular solution. Right. So we are considering y double dash plus p y dash plus q y equal to rx. Now rx is non-zero, and I'm assuming that we have already find out. So yc is already known to us. Okay, so only thing we have to find out yp. Okay, so how we can find out? So there are several way to find out this yp in the case of constant coefficient. So if p and q are constant coefficient, then there are several way to find out the yp here. Let me write it one by one, and then you'll see how to proceed. Hello? So first way is method of undetermined coefficient. We'll see what is this determined coefficient. Another way is like method of inversion. Another way is which is very powerful, and it is also applicable when p and q are uh, not constant. It may be function of x. Then also the third method is also applicable, which is known as method of variation of parameter. Method of variation of parameter. So this is also applicable when p and q are functions. It is still applicable. So the third method is very so useful. Okay. So let us first move to first method, that is method of undetermined coefficient. We try to understand why it is called method of undetermined coefficient and then proceed. Is it okay? So first let us write it, method of undetermined coefficient. Okay, so it is given here. We have Ly equal to Rx here. Now, here Ly I'm taking as y double dash plus p y dash plus q y. Now here everything can be generalized to higher order. Okay, and here I'm assuming that Rx is not identical to 0, and we can write down the solution as ycx plus ypx. So we want to find out what we say. We want to find out the general solution. So we want to find out yc plus yp. Okay, first let us find out yp here. So there are different cases, case 1, case 2, and case 3. So what is these 3 cases I want? So once we already have yc, okay, so this is already known to us. Now here we define a case 1, which is like this: no terms of this Rx is the same as the term of yc. It means that this Rx doesn't contain any terms which is written in yc. So it means that it is not Rx does not contain any solution which are linearly independent solution of the homogeneous part. Okay. In this case, your solution, a particular solution, will be a linear combination of the terms in Rx and all its linearly independent derivatives. So here, this is very important thing which we have encountered here. That first thing, everything depend on this Rx. So first remark, which is very, very important. Let me write it in bold. I cannot write it, so write it in red. That here, this method is applicable. Method is applicable only when this Rx does not contain any term which has infinitely many just hold on. हेलो हाँ मैं बोलो भाई मेरे तो क्लास है 10 to 11 हाँ तो मैं 10 to 11 है उसकी बात करता हूँ हाँ आई थिंक हाँ ठीक है बिल्कुल हमारा तो क्लास ही 10 to 11 होता है ना कोई नहीं ठीक है ओके okay so it means that does not contain any term which has an infinite number of linearly independent derivatives. Let me try to make you understand what it means. Okay, so for example, you take this sine, right? So if you look at fx equal to sine alpha x, then what is f dash x? It is cos alpha x, alpha cos alpha. And what is double dash x? It is again minus alpha square sine alpha x. So what are and we can keep on finding the derivative. But if you look at the derivatives, forms only finally many linearly independent derivatives. So here we have only sine alpha x, cos alpha x. So these are the only possible derivatives of f of x which can be linearly independent. So it is having only finite linearly independent derivatives. Are you getting this point? That this fx equal to sine alpha x has finitely many linearly independent derivatives. Right?
Can you explain
Similarly, yeah, no, I'm saying that you look at any function f of x, right, and find out its derivatives, right? And we should have only finite set which can be formed by these derivatives. Finite linearly independent set which can be formed using these derivatives. So if you look at sine alpha x, find out set derivatives. And only finite set which can be formed from these derivatives is this sine alpha x and cos alpha x, right? And we cannot have any other derivative which can be put it in. So if you find out any higher derivative, either it can be written as multiple of sine alpha x or multiple of cos of alpha. So I can say that fx equal to sine alpha x is a function whose derivative forms finite set of linearly independent functions. Okay. Another set is g of x equal to e to the power mx. Right. So we can find out the derivatives here. Yes. Somebody is saying something. Any question here? So idea is once you have a function, find out all its derivatives and we can only find out finite set of linearly independent functions out of it, right? So if we look at gx equal to e to power mx, then g dash x will be m e to power mx, which is linearly dependent to this. So I can find out only this function e to power mx, linearly independent, set from its derivatives, and it is finite, right? So this method is applicable to this. And now we look at hx equal to e to power mx sine of alpha x. You can write it like this also. Now, can you find out what are the derivatives of these? So h dash x will be what? E to power mx cos of alpha x plus, here you can write it here m e to power mx sine of alpha x, and you can find out h double dash x, and you can check that this will also form a, these derivatives will form only finally many linearly dependent set of functions. So here you will get e to power mx sine of alpha x, and you can get e to power mx cos of alpha x, nothing more. Can you check? You find out h double dash x, and all these derivatives can be written as a linear combination of e to power mx sin alpha x and e to power mx cos alpha x. Can you write it down? Can you find out the double derivative?
Yes, sir.
Okay. So I believe uh, like now look at one more thing, x to power k, make k positive, right? So if I write it here, fx equal to x to power k, then f dash x will be kx to power k minus 1, and so on. So here your linearly independent set will be what? Your constant, let us say 1, x up to x square, right? You cannot find out any other linearly independent set of derivatives. Is it okay? So it is finite. But if I look at like x power minus 1, right? Call it f of x. Then what is f dash x? It is some constant into e to power minus 2. And you can find out, and here, if you find out the set of all its derivatives, this set is not finite. Can you check that if we form set of derivatives, it will be infinite linearly independent, right? Or you can say it will be Li set with infinite number of elements in it. So this method is not applicable on this, right? So if if the Rx is equal to x to the power minus 1, this method will not work. Is that okay here, all of you? So first condition which we have put it here, that Rx is a function which does not contain any term which has infinite number of linearly independent derivatives. So derivative must form a finite set of linearly independent functions. Okay. Okay. Now, what do you mean by this case one? Here we say that this Rx will not contain any term which is already there in YC. Let us take one example. We have y double dash plus 4y dash plus 4y equal to 4x square plus 6 e to power. Right? So can you find out YC here? Please, C1. I need to fill this. Please tell me what is y1 and y2. Please tell me what is these y1 and y2. Find out auxiliary equation and find out two linearly independent solutions. your auxiliary equation will be m square plus 4m plus 4. So m1 equal to m2 equal to what we are getting? Sorry, m1 comma m2 equal to. What is the value of m1 and m2?
-2.
-2.
-2.
m1 equal to -2. What is m2?
-2.
-2.
Oh, so repeated root. Yes. Okay. So one solution we can get y1x equal to e to the power -2x. What about the other solution, y2x? Y2x will be? Yeah, somebody?
X into e raised to -2x.
X e to the power. So I can write it here, e to the power -2x and x e to the power -2. So these are like two terms, right? Now look at the Rx. Rx is this, right? And look at this first term, 4x square. And this is not matching with any of these. Okay. So it is satisfying the condition one. Similarly, this 6e to the power x. This is also satisfying the condition that it will not have any constant multiple of the term which is present in your yc, right? So it is satisfying the first condition. So in this case, your yp will be what? Yp will be the function itself. It means that like ax square and its linearly independent derivatives. So look at this term, x square and its linearly independent derivatives. So what are linearly independent derivatives? X square, x and 1. So we have ax square dx plus c. Look at e to the power x. Its linearly independent derivatives itself. So we can write d e to the power x. So this is your possible case of solution. And why it is called undetermined coefficient? Because now I need to find out only a, b, c, d, so that it will satisfy this equation. So here coefficients are undetermined, which you need to find out, which you need to determine. So yp is this. So what we have done here, we have two parts, 4x square and 6 e to the power. Look at x square and find out its linearly independent set of derivatives, which is x square, x and 1. So we got it ax square plus bx plus c. Look at the second term. It is e to the power x, which will give you only one linearly independent function. Okay, so we got d to the power x. And then put it back. So how to put it back? We write yp dash. It is twice ax plus b plus d to the power x, and yp double dash is equal to 2a plus d e to the power x. Put it back. So what you get? 2a plus d to the power x plus 4. Now here we got 2ax plus b plus d to the power x plus 4y. That is this ax square plus bx plus c plus d to the power x, and it is equal to 4x square plus 6e to the power x. Now compare the corresponding coefficient. Okay, so corresponding coefficient means look at the coefficient of e to the power x. Okay, coefficient of e to the power x. So what you will get? What you will get? D plus 4d
9
plus
9b equals to 6.
4d equal to 6. Yes. So you got d equal to
2 by 3.
2 by 3. Okay. So this is quite easy. Now coefficient of x square. Coefficient of x square will be what? We have
4a.
only 4a equal to 4. So this will give you a equal to 1. Now coefficient of x, what is this?
8a plus 4c.
8a plus x, 4b. 4b, right? 4b equal to 0. Coefficient of 1. So it is like constant basis. It is 2a plus 4b plus 4c equal to 0. So can you find out what is b here? B will be what and c will be what? Yes.
minus 2. B is minus 2.
So B will be minus 8.
P. As P equal to.
C is 3 by 2.
3 by 2.
So it means that your YP is going to be what is that? AX square. So x square minus 2x plus 3 by 2 plus is d here 2 by 3 e to the power x. So this is your YP. Are you getting this?
Yes, sir.
We'll discuss more example on this in next class. So if you have any doubt, you ask. Otherwise, we can finish this class. So any doubt? Okay. So I'm closing this if you don't have any doubts.